Hi children, hope you are fine and safe. In the last class, we discussed about graphs. There are two types of graphs. They are distance time graph and velocity time graph. Distance time graph or displacement time graph, velocity time graph or speed time graph. Hope you understand how to draw the graph and how can we calculate the distance, acceleration, speed from these graphs. Okay, today we are starting the new topic, that is equations of motion. Here there are three equations for motion. Okay, here gives the relation between these three equations of motion, gives the equations, that is the relationship between initial velocity, final velocity, acceleration, time, displacement. These three equations of motion are derived through graphical method. Graphical method means by using the graphs. Okay, first we are moving to the first equation of motion. How can we derive the first equation of motion? This part is very important. The derivation and the equation is very important for your examination. This equation and derivation are very important for your examination. So watch carefully. So we move on to the first equation of motion. That is, first we are drawing a velocity time graph. Okay. This is our here the velocity time graph. In the velocity time graph, this is x-axis and this is y-axis. In the y-axis, we take velocity and the unit of velocity is meter per second. And here we take the time, the unit of time is second. And here is the origin. Okay. Here the graph is like this. Okay. This is the graph. We can mark it as A, B. Okay. Then it is U. And we are joining this point into here, and this will be the time. Okay. This length gives the time. Here we mark D. Here we mark D. Here it is E. Here it is E, and here also we are joining this point, that is C. Then what is U here? Here also this is U, and this is this OA is equal to CD. Okay. Then here also the length of this is also U. Here OD is equal to EB. Hope you understand that. Do you clear? Here OD is equal to EB. The length is same here. So here it is T. The length of OD is T. So EB is also T. What is it? This is also T. Here is same as that of this. Okay. Then here consider a body moving with the initial velocity u and in a straight line with a uniform acceleration a. Here initial velocity u, uniform acceleration a, and in the time interval t, and it attains a velocity v covering a distance s. Okay. Here initial velocity, acceleration, time, velocity, distance. Okay, then we can calculate. Then how can we calculate the acceleration from this velocity time graph? How can we calculate the acceleration from the velocity time graph? While studying about velocity time graph, we discussed that the slope of the velocity time graph gives the acceleration. That is the slope of velocity time graph. Here is it, velocity time graph. The slope of this graph gives the acceleration. So here the acceleration can be calculated. Acceleration acceleration of the body, it can be denoted by the letter A, is equal to slope of VT graph. Okay, acceleration of the body A is equal to slope of VT graph. So what is the slope of this graph? First, we can, in order to find the acceleration of the body, we can calculate the slope of the velocity time graph. That is, slope of this velocity time graph is equal to BC by AC. Okay, here is the slope. In the mathematics, you will study how to find the slope. That is, slope of this graph is, we can find the slope of this graph is equal to BC by AC. BC by AC. So, slope of velocity time graph is equal to BC by AC. That here, BC can be written as BD minus CD. Okay. Here, BC can be written as BD minus CD. That is, here, this is the total, BD is the total, then minus CD gives BC. Okay, BC can be written as BD minus CD, all divided by AC. Then how can we write it as? That is BD minus CD. BD is here, BD is equal to V and CD is equal to U. Here BD is equal to V and CD is equal to U by AC. What is AC here? AC. What is AC here? AC is the T. That is V minus U by T. Here slope of VT graph, velocity time graph is equal to V minus U by T. We know acceleration is equal to, acceleration A is equal to slope of velocity time graph. So slope of velocity time graph can be written as acceleration A. Here we get A is equal to V minus U by T. That is, we can rewritten as, here we can multiply A into T, that is AT is equal to V minus U. Okay, A into T is equal to V minus U. Therefore, V is equal to, here minus U comes here as plus U. Therefore, U plus AT. This is the first equation of motion. V is equal to U plus AT. Here it gives the relation between final velocity, initial velocity, acceleration and time. That is, V is equal to U plus AT. This is known as first equation of motion. First equation of motion. That is, from this graph we can calculate the first equation of motion. Started from the acceleration of the body. Acceleration is equal to slope of velocity time graph. Here slope of velocity time graph is BC by AC. BC by AC. Slope of this is BC by AC. That is, BC can be written as BD minus CD. That is BD minus CD by AC. Here BD is the final velocity V and CD is the initial velocity U, all divided by T. Okay. Here AC is equal to T. Then we rearrange this equation as V is equal to U plus AT. Then we get the first equation of motion, that is V is equal to U plus AT. This derivation is very important. Here the first equation of motion are calculated by using the velocity time graph. Hope you understand this. Then we move on to the second equation of motion. Here I redraw the graph like this. I redraw this graph into this page. That is, here it is the same graph. How can we find the distance from this graph? How can we calculate the distance from this graph? by using this velocity time graph, how can we calculate the distance? Discussed in the previous class, that is distance is equal to area under this graph, that is here. Distance is equal to area under this graph. This is the area. Okay. Here we are using the distance is equal to distance covered. Distance can be denoted by the letter S is equal to area under the graph. Area under the graph. How can we calculate the area of this graph? We can find the area. Area is equal to here ABD, or what is this shape? That is, what is here the shape of the graph is like this. That is, we have to calculate the area of this. That is, we can calculate like this. That is A, B, D, O. Okay, this is the shape. This is, what is this shape called? That is the trapezium. How can we calculate the area of trapezium? That is area here. Area under the graph is equal to area of trapezium. OABD. OABD. Therefore, here area of trapezium is, what is the area of trapezium? Sum of two parallel sides by 2 into height. That is sum of two parallel sides. Sum of two parallel sides by 2 into h. H is the height. Okay, here the parallel side. What is the parallel side here? That is here, this is not parallel. Here is the parallel side. In ABD, the parallel sides are OA and BD. That is sum of two parallel sides. That is OA plus BD. OA plus BD all divided by 2 into, what is height here? Height of this trapezium means this is the height of the trapezium, that is OD, into OD. That is equal to here OA. What is OA? OA is U plus BD. BD is the V. U plus V by 2 into OD. What is OD here? OD is the T. Here we can write it as 1 by 2 into T. 1 by 2 into T into V plus U. We all know, according to the first equation of motion, V equal to U plus A into T. Then we can substitute this value in this equation. We will get half into T into, in the place of V, we are substituting the V is equal to U plus AT, that is U plus AT. V in the place of V, U plus AT plus U. Then we will get area is equal to half into T into here U plus AT plus U. U plus U, it is 2U plus AT. Okay, it is 2U plus AT. That is, we can open this bracket, that is half T into 2U plus half T into AT. Okay, here 2 get cancelled, then UT plus half into A into T, it is T square, T raised to 2. That is, area is equal to UT plus half into AT square. That means we know distance is equal to area. Distance is equal to area under the graph. Is equal to area under the graph. Here area under the graph is equal to UT plus half into AT square. That is distance S is equal to UT plus half into AT square. This is the second equation of motion. Then we move on to the third equation of motion. Here we get half into T is equal to U plus VB plus U. That is the area. Area means it is the distance. Area under this graph is equal to distance. That is S is equal to half into T into V plus U. By using this step, we can derive the equation, the third equation of motion. S is equal to half into T into V plus U. Okay, from this statement, from this step, we can calculate the third equation of motion. That is first equation of motion, V is equal to U plus AT. From this, we can calculate the T. That is AT is equal to V minus U. Here plus U comes here, it becomes minus U, that is V minus U. AT is equal to V minus U, therefore T is equal to V minus U by A. We are substituting this value into this equation, that is equal to half into T into V plus U. This can be written as S is equal to half into, in the place of T we are writing this, that is V minus U by A. Okay, into, in the place of T, V minus U by A into V plus U. Write it as 1 by 2A into V minus U into V plus U. A plus B into A minus B. You are all studied. In the mathematics, there is an equation, that is A plus B into A minus B is equal to A square minus B square. Hope you remember that. In the place of A it is V and in the place of B it is U. So we can write it as 1 by 2A into V square minus U square. That is V minus U into V plus U is equal to V square minus U square. We can write it as, that is the S is equal to S, the distance S is equal to 1 by 2A into V square minus U square. That is, we are bringing this 2A into this side. We will get here division, here comes multiplication. That is 2AS is equal to V square minus U square. Then V square is equal to, here minus U square coming to this side become plus U square. That is U square plus 2AS. This is the third equation of motion. This is the third equation of motion. Hope you understand this. The first equation of motion is V is equal to U plus AT. Here we calculated the first equation of motion from the velocity time graph, that is by calculating the acceleration from the velocity time graph. And the second equation of motion is S is equal to UT plus half into AT square. Okay, here we calculated the distance from the velocity time graph. The third equation of motion, V square is equal to U square plus 2AS. That is, we get from this equation that these three equations and the derivation of these three equations are very important. These three, there are many problems. We have to do some problems relating to these three equations. In the next class, we will do some problems relating to these three equations, that is V is equal to U plus AT, S is equal to UT plus half AT square and V square is equal to U square plus 2AS, and we will discuss the uniform circular motion. Okay, we will continue in the next class. Thank you.